Okay. All right. We started doing some combinations yesterday. A combination is a permutation where the order does not matter. I do not want to double count or count more than once combinations made from the same things. As long as it's in my combination, in my set, any order doesn't matter. So let's look at this example. A basketball team is made up of 13 players, 6 of which are good shooters. The rest are bad shooters. A starting lineup in basketball consists of any 5 players. So let's do this. Number 1, total number of lineups. How many people are on the team? How many people could be in a starting 5? How many different people? 13. I need any combination of 5 of them. I need to find 13, choose 5. From 13 players, how many unique combinations of 5 are possible? So let's first figure out how this can be done. Let's pick the players. There are 13 different players to pick first. Then after that, how many different players are there to pick second? 12, then 11, 10, and 9. But isn't that counting too many different lineups? Yeah. It's counting lineups that involve the same 5 players more than once. So I need to divide out all those different repeated lineups that involve the same 5 players, right? So let's divide that permutation by all the different ways to rearrange the same 5 players that I was double counting, or counting more than once. Now, as we saw yesterday, there's kind of a slick way to do this on your calculator. On the Desmos calculator, there is an NCR button that I can use to do this calculation for me. So if I select that and do 13, choose 5, it gives me 1,287. The same value I get by typing in this big long expression. So we got exactly 1,287 different starting lineups of 5 players for the basketball team. Did anybody have any problems remember where that's at on our calculator? How to find combinations on your calculator? Okay. I've got several other different lineup combinations that we're asked to find here for the next few questions. Number 2, number of lineups with only bad shooters. I want all 5 players on the floor to be all bad shooters. How many ways can that happen? How many bad shooters are there? 7. 6 good. So the other 7 of the 13 aren't quite as good shooters. They're bad shooters. So how many bad shooters are out there? 7. How many are in a lineup? 5. There's 5 in a lineup, right, Mike? Yeah. So my combinatoric would be 7 bad shooters. Choose any 5 of them for a starting lineup. Rather than 13 choose 5 where it's all players, I want all bad shooters in the lineup. So it's 7 choose 5. Gives me 21. Of the 7 bad shooter players on the team, choose any 5 for the lineup. Down below on number 3, what's the number of lineups with 3 good shooters? Well, there were 5 people on a lineup. If I have 3 good shooters, what about the other 2 players? They're bad shooters. So this is really asking you to do 2 different things. Find all the combinations of 3 good shooters and 2 bad shooters. I'm going to need 2 different combinatorics, 2 different combinations. How many ways are there to choose 3 from the 6 good shooters? And how many ways are there to choose 2 in the 7 bad shooters? Lunch?
Want lunch? Nope.
Nope.
Okay, thank you.
All right, so let's do the 3 good. From the 6 good shooters, choose any of 3. I also want 2 bad shooters, so let's multiply that with the number of ways to choose any 2 bad shooters from the 7 that are on the basketball team. We had 6 choose 3 times 7 choose 2. 420. How are we thinking so far? Good. Okay, let me come over here and try another few of these. Let's see, number 4 and 5 look like this. Read number 4. Think about what can be on the floor. What lineups does this describe? I want to find the total number of lineups with at least 1 good shooter. Lineups that have at least 1 good shooter. I gotta have somebody to take the shot. I need at least 1 good shooter. What can my starting 5 look like? How many good shooters could be in the starting 5? One, two, three, 4, 5. Okay. So I could sit here and I could find 1 good, 4 bad. 2 good, 3 bad. 3 good, 2 bad. 4 good, 1 bad. 5 good and 0 bad. If you want to take the time, find all those different combinations for starting lineups and add them all together, you sure could. What other option is available? How might you do this more efficiently? Because I don't want to sit there and find 5 different ways and then add them all up. What's the only one it can't be? Yeah, go ahead, Connor.
Just find the number of lineups where there's no good.
And take it away from the total number of lineups.
Yeah.
Okay. Let's try that. The opposite of at least 1 good shooter is no good shooters, all bad shooters. So let's take the total number of lineups and exclude the one that can't happen. The no good shooter lineups. Total number of lineups minus no good shooter lineups. Total lineups, we already have, that's 13, choose 5. 13 players on the team, choose any 5 of them for the total number of lineups. No good shooters mean they need to all be bad. I think we did that one earlier. There were 7 bad shooters. I want to choose any 5 of them. So let's see here. 13, choose 5. Minus 7, choose 5. Looks like 1,266. Which would be the same if I just take 1287 minus 21. I gotta have at least 1 good shooter out there. There's 1,266 different combinations that make that possible. Now I want to do a different type of lineup now on the last one. Number of lineups with more good than bad shooters. I want to have a decent set of players on the floor. I need to have a majority of good shooters. What can my starting 5 look like if I have more good than bad shooters?
You have 3 good shooters, 2 bad shooters, you have 4 good shooters, 1 bad shooter, or all 5.
So just at least 3 good, right?
Yeah.
Three, 4, or all 5 good. The rest are bad. Let's find the total number of combinations for each of these 3 different types of lamps, then just add them all up. 3 good, 2 bad. So there's 6 good to choose from. Choose any 3. 2 bad, there's 7 bad to choose from. So 7, choose 2. I'll get that figured out here on the calculator in just a second. For 4 good, let's change this 3 and 6, choose 3 to 4. From the 6 good shooters, choose any 4 now. Well, if I have 4 good shooters, that means I can only have 1 bad shooter. So change the 2 and 7, choose 2 to a 1. And then 5 good, 0 bad. So from the 6 good players, choose all 5 of them, or any 5 of them. Times choose 0 of the 7 bad shooters. What would 7 choose 0 be? How many ways are there to choose nothing? There's a way to do it. 7 choose 0. Anything choose 0 would always be 1. There's one way to choose nothing. It's just having nothing. So multiplying by 1, you can either write that there or not. Multiplying by 1 doesn't really change anything. Anyway, let's do this. 6 choose 3 times 7 choose 2. Let's get 420 again. Okay. So now I need 6 choose 4 times 7 choose 1. Get that retyped in, 105. Six choose 5 times 7 choose 0 for all 5 good shooters. My best lineup possible. Only 6 ways. All right. I need to find the sum total of all 3 of these different outcomes. So 420 plus 105 makes 525. Another 6 more makes 531. 531 different lineups with the majority of good shooters. Let's practice this. We're going to do a lot of work with combinatorics after break when we come back and start looking at probability using combinatorics. What's the probability of winning the Powerball? We can answer that using combinatorics. What's the probability of being dealt a flush in a 5-card game of poker? We got to get good at combinatorics. Here's a situation up on the board. I just give you 3 different questions. A legislative committee is formed by choosing from any 3 of 5 Republicans and 4 Democrats. Find the total number of committees possible. The number of committees where all of them are Democrats. And then since this committee probably has to make some legislative decisions, the majority is important. What's the number of committees if there are more Republicans than Democrats? Take just a minute here. I'll put the answers up and we can spot check to see how we're doing. Anybody online doing all right? There we go. You can probably see better now.
Yeah, everything's good.
Yeah, we're good.
Taking a look at this. Any 3 on the committee? 5 Republicans, 4 Democrats. How many different people can serve on the 3-person committee? How many do I have to choose from? How many do I have to choose from? No. That's So would it just be 9 choose 3? From the set of 9 politicians, choose any 3 to be on the committee.
Mr. Hanson, is this how you do it on here?
For which one? Just the first one?
So first one?
Yep. It's a lot easier than doing it the old-fashioned way. Let the calculator do all the lifting for you.
Yeah.
Now, all Democrats, how many Democrats are there to choose from?
4.
4. I need any 3 of the 4 to form the committee. Does that make sense?
Yeah.
4 choose 3. Let's see, committee's possible. Same thing. That last one's kind of difficult because if you have more Republicans than Democrats, you can have either 2 or 3 Republicans, right? So I have to do 2 Republicans and 1 Democrat, and 3 Republicans, no Democrats. So that's 5 choose 2 times 4 choose 1. I think that's 40. The other 10 come from all 3 Republicans. Yep. 84, 4, and 50. Anybody need any extra help with that? Claire, how'd you come up? But it's go backwards here. How many Republicans are there to choose? So it'd be 5 choose. And then no Democrats. This would be 4 choose 0. There's 4. choose any one of how many. Find each of those. All right, let's do this then, guys. I'll give you guys some more time to finish up that practice that is on Schoology.